Okay, so it's recording. All right, so as I said, today just pretty wrapping up a bunch of miscellaneous things, kind of get at the end. Nothing here is difficult, but it should be fun things, interesting things. So, all right, so I'm recording here. So let's go to, the scavenger hunt. Let's read through the document. It should be here. Okay. All right. So this is the scavenger hunt for 2023. Basically kind of try to make it this year as a actual physical scavenger hunt in a sense. So break into the CIA vault. The vault just meant the file, right? So that was the encrypted file, and retrieve a secret of great importance. To break into the CIA vault, you need to find a code. This code is actually made up of 3 other codes that must be concatenated together. So that was you needed to find all 3. The 3 codes are stored in the vaults of JP Morgan Bank in Washington, Mackinac Island First Bank, and the Kremlin. All right, and basically they're just 3. Oh. Was it never on?
It was on.
It was on.
It was on.
Okay. Oh, yeah, there you go. So the 3 codes are stored in the vaults of JP Morgan Bank in Washington, Mackinac Island First Bank, and the Kremlin. So these are just 3 files that are encrypted. You will first need to break into these institutions and retrieve the respective codes, right? Once you find the secret of greatest importance, you should provide it, and good luck. So that was kind of the gist of the problem, right? And so basically you just have to go. Now I dumped all the files into Brightspace, as you know. But basically but I provided the code, right? So I provided the code for each one, and I labeled them by bank. So that was kind of my suggestion, that you guys should group them, right? So now let's switch over to the virtual machine. Okay, so we're going to switch to the VM. And you can see I already grouped them here. All right, so I grouped them here. CIA, JP Morgan, Kremlin, Mackinac, and then I just left the 2 keys there, right? So the basic idea was for you guys to have a sense of, you needed to break each one of these, one at a time. They were all 3 were independent, really, and then you just needed to gather the code so that you could get to the CIA code, okay? So I'm going to open up the terminal here, and you guys can help me out to solve it. Okay, so we're going to go into desktop. And then I was practicing on this one before your exam. All right, so there we are. So these are the 3 ones. So can't remember which one. Oh, the Kremlin one was probably the easiest one, right? That was pretty much kind of like a trick there, right? So if you go into this one, you have the AES vault Kremlin encrypted .bin. So that's the vault. That's the file that contains the secret. Then I provided the Python script, of course, to decrypt it, right? So you have the code. And then I did provide a clue. Oh, and I have this. All right, so let's look at the code. So that was kind of a good approach, right? And if you look at this code, I think I already have it in there. right? It's basically a standard AES encryption, right? So you've got your AES decrypt in there, right? And so this is the AES Kremlin encrypted, right? And so you wanted to get the message. So this, I think, was not there, but there was a clue in that this is 16 bits, right? So that's 16 bits, gives you an idea. So you needed to find this number, right? You needed to find that number. So if we do, I provided a message in there. We can do top secret communication. And so it says in that the Russians have implemented an insecure cipher, which is something we had talked about, right? That sometimes you can have an insecure implementation of an algorithm. So we can derive the key from intercepted ciphers and messages. We know the block and key are size 16 bits, and we intercepted plain message and a cipher. So you learned from XORing, it was one of the problems that we did, right? That we could take what? A plain and a key, XOR it, and get a cipher. And then remember, one of the quizzes that we did was to take the cipher, the message, and we can XOR it to get the key back, right? So this is the basis of this. So with these two values, you could take the XOR of them, and that would give you the key, basically. Do you see that? So this is the plain message, this is the cipher. You can XOR it by hand. You don't have to write a program for it. So literally, you can just solve it by hand. And then now that answer should be added to the code. So we're going to go in here. Code, yeah, that one. And so the code should be, if you XOR those two numbers by hand, you get 1101, 1001, 1000, 1101, and that's your key, basically. That's it. So that's actually the easiest one, as long as you had that little insight in there. All right, so now let's go ahead and run it. So this should give me, okay. So all you have to do is plug that one in there, and it should be 54321. All right, that was secret Kremlin. All right, so you've broken or you've hacked into the Kremlin, basically. So you got that number. Now we can go, one of the ones that was pretty, I think, which one? Oh yeah, the Mackinac Island, I think was that the RSA one, Mackinac? Okay, so let's do the other one. The JP Morgan one was literally like the demos that you guys did. Like there was nothing there in that. So let's do ls-l. So JP Morgan. Okay, so we go in there. Oops. No. All right, so JP Morgan, if you notice, this one had more files, but it should be just very standard AES and RSA. That's basically it. So we can look at the files. We have AES hack JP Morgan vault, right? We have, that's the code. Then we have the corresponding AES vault JP Morgan encrypted. So if you remember, we use AES to hide our secrets, right? Then we needed, so we got encrypted AES, we got cipher, AES, oh, the key, right? So obviously we need a key to be able to break, to use AES. And so we've always hidden the key. So you have the code RSA hack JP Morgan, and basically then we can start with that file. So let's take a look at nano RSA hack JP Morgan. Okay, so this basically is for what? We have the cipher AES key JP Morgan.bin, right? This was sent to you, and you are the agent, basically. So you can use the agent private key. Do you see that? So it's really, the assumption is that somebody used your public key, the agent public key, to encrypt, and then you can use agent private key. You take cipher AES key JP Morgan, and that's going to generate decrypted AES key JP Morgan. So it gives you the key that you're going to use for AES, but this key has been encrypted with RSA. Does that make sense, guys? All right, so let's go ahead and run that one. So this should generate the file. Okay, so now we would have decrypted AES key JP Morgan, and now we're going to go to the code AES hack JP Morgan vault. Okay, all right, so then we go in here, and if you notice, this is the vault where the message is actually hidden, right? Because we've established many times that AES is what we use for confidentiality. We read in everything, and we are going to need the decrypted AES key from JP Morgan, right? Which we already have, and then we can just proceed. So we're going to do Python. All right, and that gives us 1, 2, 3, 4, 5. So we've got 2 of the secrets, and then we just got the 3rd secret, which is the one I said to you guys, you're going to have to factor RSA, right? And that was Mackinac Island, right? So we're going to go ahead and go into Mackinac. All right, so here we have then the code to hack Mackinac Bank, the Mackinac Bank vault, okay? So this will give us, we also have Mackinac Bank public key, Mackinac Bank, and we have Mackinac Bank vault, okay? So we can take a look at Mackinac vault. And as you can see, that is the cipher, right? Mackinac Bank Vault, that's the cipher that you need that fits into the format of your RSA, right? So remember that in cryptography, cryptanalytics is about looking for patterns also, right? So you gotta like have that watchful eye for a pattern. So here we have this numbers. We can also look at Mackinac public key. So that's gonna be cat Mackinac, oops. And you can see I wrote down public key E N, right? So we learned that to break RSA, we can take a public key. The idea would be that we get N, we need to have a special type of a computer and factorize this, right? So this is the number 6818, that number, that's the N. We would plug that into FactorDB, and then that would give us 2 numbers, okay? The 2 prime numbers, P and Q, right? So, you know, that number, once we have those 2 pieces, then we can go to code. Okay, so that's the same script that we always use. If you remember, you just have to scroll all the way down. And as you can see here, these 2 numbers are what FactorDB gives you, P and Q. Those are your prime numbers, which you should know P times Q gives you N. All right, so we take those P and Qs, and now they're going to come into this function. You needed to change what I wrote on the files that I gave you is I gave you this. But it was all zeros. All you had to do was replace those zeros with the values in the cipher file, as we did in the examples. And then basically, that should be it. And not only have you broken RSA, but you should be able to get the final code. So let's go ahead and run that one. So that's going to be Python. And there you go. Your secret was 101010. That's it. As you can see, the numbers are not difficult, but this was the scavenger hunt, just, you know, breaking all the concepts. Now we can finally put them together in the final. So we go to the CIA vault, and we want to break that one. All right, so here you have a vault at CIA encrypted bin, right? And then there's code to hack the CIA vault. So you go to the code, All right, and you're going to read in the file just like we did before. Notice I've already added the secrets: 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 0, 1, 0. Okay, then I just concatenate these, and notice that we're basically just using AES encryption. Okay, so I'm going to go ahead and run that one. And that's the secret. Can anyone tell me where that's from? Or is that too cryptic for you guys to know where that's from? It's actually from something. It's Rick and Morty, that's right. Yeah, watch the episode. It's pretty interesting. All right, so yeah, that's from Rick and Morty. Formula for concentrated dark matter: 2 parts plutonic quarks, and 1 part cesium. That's it. That's, fun, hopefully. And yeah, that's the scavenger hunt solution. Okay. All right. So I will, well, that's it for this demo. All right. So I'm going to stop sharing here. And I'm going to stop the recording.